Hello and welcome everyone to a podcast episode of Video Analytics 101, where we are talking to industry leaders in the fields of AI, from research, but also from industry, and talk about the technology, where it's going, what are trends, and so on. Today, I'm super excited to have Jean-François Gagné with me. He is one of the people who are very deep in the AI field. He's an entrepreneur. He's a consultant right now and has shaped the AI field like few others, specifically in Canada, but really globally. He was one of the founders of Element AI, which was a big AI company in Canada and still is. And GF can talk a little bit about this. So thank you, GF, for coming here and talking to us about this. This is really an honor, and I think it will be super interesting to our users.
It's a pleasure to be here, Florian.
Cool. So maybe let's go back a little bit in the beginning and talk about how did you get into this field, which I believe was before all this huge boom happened in AI. So how did you get into
AI? Science fiction books actually got me in. As a teenager, I was fascinated by the idea of robots and the potential that software could have in helping people in all sorts of ways to support us around all sorts of tasks. And I was very just fascinated about it, and that's really what got me interested in the first place. I've always been very curious, so I tried all sorts of things when I was a teenager and then my early adult years, and started to learn to program and got interested into robotics and studied a little bit on it, and then figured out that the best way for me was to get into it, was to start to use what I've learned at that point, and then try to package products and sell it in the market.
So did you teach yourself this stuff from coming from robotics, or how?
It's a mix of I did a little bit of some classes, but then a lot of self-learning, and then just through collaboration with friends, and
cool.
And after that, just executing on projects and starting to build products, like just got me to improve consistently.
I can really resonate to that. Something similar happened to me like 18 years ago or so, where we also were playing around back then with computer vision. And we had the feeling that in academia, people always try to make it more accurate and get better and better and better, but nobody was using it. So we were also saying, okay, come on, let's just do something. It might not be 100% perfect in the beginning, but at least somebody can use the technology.
And there's a huge sense of satisfaction. I think, given the nature of this technology, I've always been staying very close to the research side of things, because there's been so much progress. So, over the years, to keep your edge, like doing a lot of technology transfer and staying close to research has always been one of my key to success. But there's that satisfaction of building something, implementing it, and then seeing it work, seeing it, have an impact in real life. It's always been like a thrill of mine.
Yes. Holding in hand the first customer PO is a magical thing.
It's sometimes painful, but always very satisfying when it works.
Thinking, wow, somebody's paying me for what I'm doing. Amazing. It must be cool. Okay, so but for those people who don't know what Element AI is, maybe you can quickly describe what it is, what did you do, and so on.
So it was my third startup. So what I was talking about was around my first company, where the bulk of the work we've done was actually to use advanced techniques around machine learning and some operation research, and then we've implemented it, often mostly custom implementations.
Mm-hmm.
I sold my participation in that business in 2007 to create a second company, That was software as a service product focused around, yes, AI technology, broadly speaking, but at solving the problem of planning, schedule, and organizing people schedule in the service industry. That was my second business, exited. So Element AI was my third one. And it was an interesting timing for us, where in the market back then, like I think 2015, we were seeing a lot of progress. Felt a little bit like what we're seeing today around generative AI. Probably a bit less intense than what we're seeing today, because I think today it's a lot of excitement around the cost of deployment, and we can talk about that later, but about the barrier to entry really lowering. Back then it was more of an excitement of, oh wow, there's a lot of stuff that can be done with this technology that we never thought possible. And that opens up a lot of possibility. Now, a lot of the work was being done and directed, the research and the applied work was directed towards consumer tech in general. So a lot around advertisements and targeting, recommendation system, etc. And not a lot was actually done towards the enterprise. So broadly speaking, more boring tech, but stuff that enterprise would need. Yeah. And the thesis for Element AI was to build and create an organization that would have similar type of capacity as a lot of the big labs, directed towards consumer tech, but directed towards enterprise tech. And that was essentially the vision for Element AI. We put that together, myself, my co-founder, Nicolas Chapado, Yoshua Bengio, Philippe Baudouin, Anne Martin. So there was a few of us coming together to create the business, and basically, went out and offered it to the market, and the response was quite overwhelming.
So, can you give one example what it would mean? I would imagine putting AI in ERP systems or so, maybe recommending new customers to the sales team. Like, what are examples of what it did?
So, the interesting story here is, I was saying that we got an overwhelming response. I think there's many facets to it. So at first, there was a 2015, 2016 organizations were still extremely immature in understanding what does it meant for them. Where were the opportunities, and a lot of the work was about just figuring out what was possible for them to actually go on. And by possible, I mean to the contrary of what we're seeing right now, with a lot of the foundation model now reaching critical point in terms of capacity, either it's from language or like different types, and being relatively easy to deploy, not too costly to deploy before they drive value. Back then, what we discovered was that, yes, we could achieve high degree of accuracy of performance around some certain tasks, but the work to do to get the data right, to get the data pipeline in a good place, to put in place the right governance and everything was extremely costly. And often a lot of the infrastructure that you would need to do the calculation, to train the models, to deploy, like to capture the data, was missing. So our realization was early days, hey, like we can do a lot of proof of concepts. And when it gets to roll this out at an industrial level at scale, like 90% of the work we got to do has nothing to do with AI.
Yeah.
And that was like one of the first early realizations. So we ended up doing a lot of that type of work, slowing down a lot of the fancy stuff we were hoping to be able to do. And only later on, like a few years later, we've managed to come up with pure AI products that were like flashy and interesting. So, I mean, yeah, some of the stuff we've done over these years were like deal with all sorts of documents.
Mm-hmm.
Think of all the paper that's still in so many organizations, and it's still true today. And provide a seamless experience and how you can automate or augment the work of absorbing all of that information and then driving decision on the other end. So one of the product we ended up building was around the whole automation around documents.
Okay. I just want to echo your point around you need so much infrastructure around the AI itself. That's also my personal experience in computer vision, where in the beginning we thought, okay, we just put all the computer vision PhDs in the room and there will be a product at the other end. It's not the way it works. And what we see is you need at least, for every computer vision guy, you need at least 2 full stack devs, rather 3 or 4, in order to productize this. So eventually, in order to create an AI product, you don't need so many AI people, but you need a lot of people to make this actually work.
No, it's true, and it's still true that, by the way, like for lots of use cases, a lot of situation, it's still the same today. Yet foundation models are changing the game a little bit, and that's very exciting. So the return on investment equation is shifting these days. So I think we'll see way more adoption than we've seen in the last 5 years in the next year or two. So that's very, very exciting. But for so many other use cases, like it's still the reality. You're gonna spend an awful amount of time getting your infrastructure in place.
And sometimes every project is a project. To commoditize this is not so easy.
No. But there's hope. I mean, what we're seeing for a language, there should be ways to create similar types of models applied to different other problem space. So I'm quite hopeful to see all of this, evolve in the right direction, and to see this technology being able to have more and more impact.
Maybe one question around the founding of Element AI. Yoshua Bengio, obviously super famous, considered one of the godfathers of AI. How did you meet, and how did that work?
We connected first in 2003, if I'm not mistaken. So part of my first company was looking for people to help me do all sorts of forecasting tasks for some of my customers, and ran into Yoshua and also Nicolas Chapato. So both of them were co-founder also in Element AI, and they had a business together, Nicolas and Yoshua. So to do technology transfer from Yoshua's lab into the market. So that's how I started to collaborate with them. And since then, like, it's been active collaboration, and now, I mean, it's a friendship and beyond. But like, point is, that's how we connected a while ago. That was way before neural nets were.
Yeah. But of course, it's super in regards to what you said about keeping up with the research, because what he's doing in his lab for sure is at the forefront of what's happening nowadays.
Yeah, I mean, a lot of the apply work I've done has been limited by just the capacity of the technology.
Yeah.
So, and as it's been expanding, like my playground's been expanding, so I broke free from old, quite narrow use cases of like routing vehicles and trying to predict demand for sales and different stores, and like some very simplistic tasks to like very sophisticated one of like making like root cause analysis and generating potential solutions for problems in manufacturing out of like data and text, and then like very fancy type of products.
Mm-hmm. I mean, obviously the whole large language model boom will change the game completely. What I wanted to ask you, did this surprise you that this came now? ChatGPT and GPT-4, was it as surprising as for the general public, or were you expecting this anyway?
I mean, I think we all got caught by surprise, and we started to all feel it, I'd say, in the field at some point last summer, certainly last fall. Like, there was something that was happening. We were hitting on something different, and I think everyone got surprised by the emergence of a lot of abilities, and I think that's really what's the news here. It's hey, we've hit some threshold of quality of the tokens we're training on, and understanding of current architecture paradigm, and some scale, and then that is actually enough to see certain quite advanced properties emerge, and it's then like we all have that same thought process of, hey, okay, then this is just not that much more than what we were doing a year ago. What about the same amount next year? Yeah. What is going to emerge? And something will or will not. And what is it going to be? And do we understand why this emerged? The answer is like, we don't know.
The concept of emergence, that something is suddenly happening there that was unexpected, I think this is part of the magic component. It feels like, oh my God, something's happening that's not supposed to be there, but it still is.
Yes, and it's true for good behaviors, but it can also be true for behaviors that are undesirable. So it's true for desirable behaviors, but it could be also true for undesirable behaviors. And I think a lot of the calls, letters, and a lot of the stuff that we see now coming out, I think, is quite appropriate, which means that, hey, like, let's not get too ahead of ourselves and make sure we do our own work of figuring out, how is this happening and why is this happening? And
did you sign the letter?
I've been part of a lot of these groups, but I'm behind these letters. Generally speaking, I think some of them were specific and created to probably bring attention to them more than to be necessarily a realistic outcome. Stock research, okay, like, not sure, but realistically speaking, I think the spirit behind it is absolutely founded and grounded in a good rationale, which is to, hey, like, we just can't stop. We can't just keep going without building that better understanding of how these things works, and why are we seeing emergence of certain properties, and getting better at predicting and understanding and controlling these emergent properties around the models. And one thing I can tell you, and it's been true, like there's a direct link whenever you're building a model between your ability to understand the increase in performance, accuracy, and how a model fail, and the ability to then improve them. So all of that effort is not wasted. There's actually, I think, an economical rationale that is sound to put a lot of energy into making sure we understand what we currently have, and just doing that will translate into better performance anyway. And I think that just going bigger, more scale, and just continue to run blind would be more detrimental, create more risk. And yes, maybe you would have like another set of property that emerge, but it's just kind of playing roulette.
Yeah.
Because you don't know.
But there are many podcasts of people talking about this. My feeling in general is that everybody seems to agree that this is an issue and we need to do something about it. Maybe they don't agree so much exactly how and how much. But when I listen to podcasts of Sam Altman, I do have the feeling that they talk about this in OpenAI and they have things in place to make sure and so on. And I guess you can always talk, should it be more, should it be less? But I have the feeling that everyone in the industry somehow has a feeling of we need to do something.
Yes. And I mean, there's a beginning of a movement to invest more time and energy into this. We'll have to see. The competitive pressures are still there. I mean, if you listen to different people who in the field who are quite vocal, who think that was true, like they expose that the shareholder pressure and the competitive dynamics, the game theory aspect of this dynamics will force everybody to just keep going faster, keep going bigger, and just run in that direction.
I think this is what Max Tegmark always refers to as the Moloch.
Yeah, the Moloch. Yeah, okay. But yeah, no, that I was thinking about him. So correct. And it's, you can't deny that that's not at play. Yeah. Yet what we can certainly do is to motivate and bring enough people's attention towards dissecting and trying to get to the bottom of how is this happening, and I think that's the right call, like to invest significant money. So on from my perspective, I've always been a huge proponent of transparency. So first, and then we're getting some transparency here, not all of it, but some, and then education, making sure people understand what are these risks, and when we're doing that by talking about it, and then it's to focus on the right next steps, and the right next steps is calling stop and going against the competitive dynamics is I think it's a tough proposition, but to actually invest, support, and having governments and academic institutions and like whatever organization has ability, time, resources to devote and focus these resources towards growing our understanding and making sure we have control and then drive alignment. I think is the right path around the tech, and it's not something that will magically happen. It's something we need to consciously decide to focus on.
I found your I think LinkedIn blog post from a few years ago where you already talked about this, and we'll get into this in a second. But are there any best practices or so that you have from your days in Element AI on how companies can actually implement this? Is there like a checklist, a set of principles, a processes that you can implement?
So I mean, this has been true for all systems, like all models. We talk about large language models now because the emergence of these capabilities, where there's science that needs to be done to figure out exactly how to be on top of these ones. still, yeah, there's frameworks. So I suppose you're referring to my governance framework.
Yes, I believe that.
That I've published a while ago. Yeah, I mean there's that direct link I was talking about, and really this is something that, as you're thinking about deploying models at scale in any organization or in any product, there's a lot of things that you'll want to put around them, and to be able to understand how they behave and how they react to situations. You'll want to make sure that you've got a good understanding of what can they do, what's the envelope of their performance, their accuracy, how precise are they, where they fail, and to monitor that. Basically, you need to think about your governance envelope as a like unit test for software, and you got to put that in place, and keep your finger on the pulse at all time as an organization, because a lot of these systems will evolve, and will, as you provide them more data, you retrain them. Every single time you need to understand how this evolves. So if your self-driving car software struggles to deal with light refraction when it goes into the snow, you want to basically characterize that and make sure that at that point you hand over driving to the driver, as an example.
Yeah.
So it's the same thing for a lot of these models. Understanding where they break, why they break, how they break, and what can they do, what level of accuracy you get, what confidence you have in whatever task you're asking them to do, and then decide how to manage each situation.
Yeah, and I believe how do you manage it also depends heavily on your application and the criticality of it. A self-driving car is probably a little bit more critical than, I don't know, counting people at an entrance, where you don't care if you miss one, but you do not want to have the self-driving car not being accurate. And the same thing with explainability, I guess, where the more critical the task is, the more important the explainability gets, and the other things, and bias and so on. But yeah, I completely agree. I mean, any kind of application needs this, what you call envelope, and probably be implemented, I would say, as a gating process in your release cycle. So the last, or one of the checks before you release something, all the principles have to be checked first, right?
So the nuances when you get with bigger models is to guarantee alignment between your objective and the model objective, because it gets very large, very messy, and complicated. So the way you can express your goal can be understand different ways by these very large models. And that's really where you see quite a distinction between narrow AI, so AI that is really centered around very simple task, like I'm trying to predict, I'm trying to recognize like the speed limit in a certain zone. That's a narrow model, versus something like get me to a location safely and quickly. That's vague. How do you ensure that what you have in mind in terms of goal is aligned with what the model will deliver to you? And then in that space, that envelope of risk and probability of doing it, are you comfortable with the model getting you a slightly faster, but then like taking more risk at an intersection, or not? And and this is where, like, the bigger the model, the more sophisticated it is, the more that alignment problem becomes an issue. And then the more power you give to that model, the more it's important that this alignment is correct.
Yeah, of course.
So this is the dilemma, and that dilemma is a continuum, right? It's not something that you'll say, oh, it's at this size or this types of problem. This requires a thoughtful analysis
Mm-hmm.
of each situation, and then basically, you as an individual or as an organization scoring, hey, do we think that the consequences of a misalignment here are very severe or not? And then can we actually box this system and then put validations or hard constraints around it?
Yeah.
So that even if the objective is not perfectly aligned, we'll basically correct it elsewhere at a different step or not. And then so all of this is part of that design. So, there's the overall governance of models and how they're used, and then there's that that governance of a single step or a single task in the model. And then you got to use these different lenses as you're implementing the technology and you're thinking about it.
You mentioned narrow AI, and for a while, at least me, I was basically saying we can only do narrow AI 5 years ago or so, and it was always narrow AI versus artificial general intelligence.
Mm-hmm.
Which begs the question: is it AGI now, or is it a step in between on the way there?
I think we're finally seeing the beginning of a path towards it.
Mm.
I think, and what I was, if you listen to Hinton or to Yoshua, and I think that what's fascinating is when you compare to human intelligence, you look at the ability and the efficiency of a lot of the algorithms we now have access to compress knowledge and compress information that is way better than the brain we have. And you look at the emergence of certain abilities that are happening at very small size of model, and compared to the human brain.
Yeah.
And we've always been AGI, we don't know. Maybe it's that far away because look at the neurons in the brain, look at animals, look at this, look at that. And I think what we're starting to realize empirically is that, hey, maybe we don't think their current algorithms or architecture are that sophisticated, but they actually work, and maybe they work better than the human brain, and maybe we don't need such a large neural net to get to more general intelligence. And I think it's part of the debate and the fears and all the emotions we have right now, right?
Yeah.
It's oh, maybe we do have a path that is a shorter path than what we were thinking. Because we were we're 10 years, 15 years away from having a computer with as many neurons as the brain.
Yeah.
But I don't know what's the number, but if the neurons we use, the artificial ones, and the algorithms we have compress information better and are faster to iterate, and you actually need 5 times less, 2 times less, or 10 times less, well, maybe that frontier is 1 or 2 generations away from current models.
Yeah.
And then what do we do? If we've not solved all the things we've figured out, we just discussed.
Yeah. One thing that's why this whole development of AI surprises me is because I've experienced so many times in other fields of technology that you have a certain revolution, you have one big paper, and then you have a boom, and everybody is extrapolating the same advancements into the future, and is saying, oh my God, if you continue this way in 2 years, we'll have this. And very often what happens is it doesn't happen. There's a plateau, and it flattens out, and it doesn't progress the same way it does. But with AI, it's the opposite. It's exponential. I would have thought that we have reached pretty much what we can do, and then there will be a 5-7 years research thing, and then there's another boom or so, but it's continuing and continuing. And I don't know. In my personal experience, I haven't seen that before, that it always continues to improve and get better. And obviously there's the same question now with large language models. Are we 2 generations away or not? Who knows?
I mean, better models right now are giving us better tokens. Better tokens will get us better models. And then therefore you can train smaller models to perform as well as the prior very large ones, because you've curated and you've created better content for them to learn.
In reality, I mean, we need to spend so much time on making smaller models better as well, because it's really hard for research to work if you have to spend $1 billion to train your model. It just doesn't work.
And you're getting better architecture from a hardware perspective, with the latest release and on the hardware chip side, and that will yield better models, bigger models. So you have like all these self-reinforcing feedback loops right now that are all contributing to accelerating this field.
Yeah.
And as you compress better information and less, and then you share this prior acquired knowledge to the next model, and then you expand their ability to take on new tasks. I mean, you get that kind of acceleration, and now like everything you can do around language, and then the translation from language to image, understanding a scene, understanding information that comes from the visual field, and then you add other data modality. These models then are going to start to create better world understanding. And then I mean, like the next steps are quite obvious. Like if you have models that have this better world understanding, why couldn't you create tokens that are a better training set for world understanding for the next generation?
Yeah.
And then like it's like we've needed better tools to be able to work at with microscopes, to work at a smaller scale and be more accurate. And as you've been able to do that, then you could build better microscopes, and then like we could then work at a smaller scale, and same thing with laser and like all these technologies. It's the same thing with intelligence.
And since you mentioned video, that's obviously super interesting for the security field. If you can make this work, I believe today it will be still difficult and very expensive, but for sure it's going in this direction.
Well, yeah, and
complete scene understanding.
You go very fast. You can see like some of the demos that I think NVIDIA published recently around manipulating videos and generating videos. So I think there's some work still to be done around figuring out the right user interface and how to interact and then manipulate information. But it's just a matter of time at this point. It's not a matter of like, is it possible? It's just a matter of time. I think we're on that path.
So how long do you think it will take until we have Hollywood movies made by AI?
I don't know if we'll like a comparable quality.
Yeah.
My guess would be that we're 5 years away from that. That's my guess.
I feel like there's still a lot to be done. If I look at the demos, it's very impressive by itself, but if you compare it to a real movie, it's still far away.
Correct. But never forget that this is a collection of parallel trends that are all like individually improving.
Yeah.
Telling a story, the narrative, like the mimicking of humans' emotion, and like all the subtleties around different situations. Like all of these things are being worked in parallel. So you get compounding benefits. And then connecting the dots between models used to be something that required quite a bit of work. And if you look at one of the big advances we've got around like code generation and everything, is that sharing information between systems now is becoming ubiquitous. Very easy. The barrier to connect APIs, to connect systems, to share, like to translate information between one format to the other one, the cost of doing that is plummeting. So, and this has not been expressed and fully seen in all the systems and everything that we use, but over the next 12 months, that's going to be an explosion in value that we're going to be getting from all systems. Like the era of like reconverting data and then filling missing data and course correcting and everything where it was painful and a lot of work, that's coming to an end.
Mm-hmm. I want to make sure before we run out of time that we talk about the European AI Act. I believe you were somewhat involved in the beginning.
So I've been part of the high-level expert group on AI. I represented Canada as a help to their European Commission. And I've been part of creating all the early reports on providing all the guidelines around artificial intelligence and how could it be trustworthy for society. And it's been it lasted over almost 2 years, spending going to Belgium every month, I think, for 2 years. Okay. So quite of a commitment on my side, but I thought that the timing was right back then, 2019, 2020, to do that work. I think it's been a good contribution. And then from there, the European started to work on creating the AI Act based on
and
the
you
work.
Still think it's relevant, I guess.
There's a lot of good in there. I think, unfortunately, like a lot of these things, sometimes the politics get involved. So we'll have to see what lands and how is this created. I think some of the latest addition that are being tried to be pushed in are rushed, and I think I would advise for caution.
Like the fines or?
The fines, but also a lot of the regulation around large language models, for instance, and generative AI. I think fear or political agendas are coming in the way of doing the right thing. But that's just an impression from a distance, honestly. Since after I sold Element AI, I worked for a year for the acquirer, ServiceNow, and I've been taking a little bit of a break for the last 12 months. So I've not been part of active conversations. I want to be careful, more of a educated spectator, let's say, at this point of like, I don't know what the details are on all of that stuff. But from a distance, this is kind of my opinion. I think they should be careful and release something that is a good first step instead of trying to cover everything. What
I'm also wondering is, well, first it's a balance between doing the right thing and also hampering innovation. I mean, you have to consider this in Europe as well, especially if other countries are not doing it. That's one thing, and the other thing is if you keep adding stuff every time there's a new ChatGPT, you will never be done. They're working on this now for 3 years in a field that's so rapidly evolving. I mean, they will never catch up if they don't release it at one point.
No, yes, and the I think that one of the things that was out of the guidelines we provided is to showcase that a lot of the anchors already exist in bodies of laws that are already in place around making sure that people are not manipulated. There's a lot of laws around that. Making sure that there's transparency and you understand what you're buying, and what you're buying is what was being delivered to you. There's a lot of, let's say, fundamental rights and pieces of the law that is there already that needs to just be connected and applied to this field of AI, generally speaking. So ChatGPT should not manipulate you. period, or any other models should not be there trying to manipulate you, period. So you don't need that. You need to just create the right envelope so that it's not too onerous for you to get this to be enforced. But you got to be careful, yes, to not hinder innovation and create a disadvantage for European organizations when it gets to go out, innovate, compete, and then drive value for people. Because there's, like, we talk about this, and of course we want to make sure we cover for the risk, but the benefits are incredible. The gains and everything that people can get from this is just incredible. And for anyone who's tried these systems and learn how to prompt them properly, I'm sure that you've all discovered that the potential and the time that it can save you, the increased understanding it can provide you around certain questions, nuances, and to understand certain phenomena. Like it's not something we've had access before, ever. We were depending on someone writing the exact blog for our question on a website that Google can crawl and point you to.
It's so stupid, right? Actually.
And now we have systems that can, digest a lot of that information and then provide a crafted, personalized answer to the right perspective that you're trying to look for, and then hopefully can provide you the source and everything so that you make sure they're not hallucinating. But that's I think it's a huge amount of progress.
I think this is a great note to finish, because yes, we need to do the right thing, we need to do it properly, but it can be such a force for good. It could be a revolution for humankind, and I think this is why we are all in this field, because like this excitement is there, and I can feel the excitement with you.
No, it is great. And it is a field that keeps on giving, like I don't think any other. So I feel very blessed to have been able to be part of this, and then to still be writing this. It's amazing.
I'll be looking forward to what you do next, and what next you will disrupt. Thank you for joining, Jeff. This has been super interesting. We unfortunately ran out of time. Thank you for joining, and again, I will look forward to seeing you revolutionize this field further. Thank you.
Hey, thank you, Florian.